Welcome to my presentation. My name is Asmita. By seeing the picture, we can say that the people standing in a lane for a ticket counter, the people who enter the ticket counter first will take the ticket and leave the counter first. So it follows the principle first in, first out. So the topic is queue in data structures. Let us see what is queue, what are the operations in queue, advantages, disadvantages, and what are the applications of queue. First of all, what is queue? Queue is a linear data structure in which insertion occurs through one end called rear and deletion occurs through another end called front. Queue is referred to be first in, first out. We have seen in the previous example. For example, people waiting in a line for a railway ticket or for a movie ticket. Let us see what are the basic operations in queue. There are 5 basic operations in queue, that is enqueue, dequeue, is empty, is full, peak. Enqueue means adding an element to the queue. Dequeue means deleting an element from the queue. Is empty means checking the queue whether it is empty or full. Peak means getting the value of front of the queue without removing it. Working of queue. We have seen that there are two ends. One is called front, another is called rear. Front track the first element of the queue, rear track the last element of the queue. Initially, the value of front and rear is -1. Let us see what is enqueue operation and what is dequeue operation in detail. Enqueue operation is nothing but adding an element to the queue. While adding an element to the queue, we have to check whether the queue is full. That means rear equal to maximum minus 1 means the queue is full. If it is not full, then we have to set the value of front to 0 and increase the rear index by 1. Add the new element to the position pointed by the rear. What is meant by dequeue operation means deletion an element from the queue. We have to check whether the queue is empty. Queue is empty means front and rear values are -1. If it is not empty, then increase the front index by 1. For the last element, set the front and rear values to -1. Let us see enqueue operation. While performing enqueue operation, while adding the first element, we have to set front value to 0 and increase the rear by 1. Let's see here we have set the front value to 0 and we have incremented the rear value. So both are pointing towards the 0th index. While adding one more element, we have to increase rear by 1. So we have incremented the rear value by 1 in enqueue operation. In dequeue operation, while deleting, we have to delete elements from the 0th index. So we have to increase the front by 1. While deleting the last element, we have to reset the values of front and rear to -1. First, we will see what is meant by null operation. Actually, null means empty. When we will say that queue is empty means when front and rear values are -1, then we will say the queue is empty. That means there is no elements in the queue. Otherwise, we will say that queue is not empty. Let us see what is meant by full operation. Full means the queue is full. Then we can't add any more elements in the queue. If rear equal to max -1, then we will say that the queue is full. What is meant by peak operation? Peak means topmost element in the queue. Helps in extracting the data element where the front is pointing without removing it from the queue. Peak means getting the topmost element in the queue. First, we have to check whether the queue is empty. Empty means front and rear values are -1. If it is empty, then return queue is empty. If not empty, access the data where the front is pointing, and we have to return that particular data. Let us see some of the real life applications of queue. We will use queue in printers. Queue data structures is used in printers in order to maintain order of the pages while printing. Queues is used in software applications too, like Swiggy, Zomato uses a queue for maintaining food order status. We will use queues data structures in process scheduling in operating systems and also in switches and routers. We'll also use queues in customer service systems. It develops call center phone systems using the concept of data structures. These are the pictures that represents the applications of queue. The first picture is the printers. We will use queues data structure in printers. in order to maintain the order of the pages while printing. We will also use queue data structures in operating system for task scheduling, switches and routers, and also in call center phone systems. Let us see what are advantages and disadvantages of queue. Advantage means multiple data can be handled and they are fast and flexibility too. Disadvantages means we should delete an element to add new element to the queue when the queue is full. We can conclude that queue is a linear data structure which follows the principle first in, first out while studying the previous slides. Thank you.